So in addressing modes, we have already discussed immediate addressing mode, in which the data is the part of instruction, and after that we discussed register addressing mode, in which the register will be used to store the content, and after that we discussed about direct addressing mode, in that the offset address of our data was given in the instruction. And after that we discussed about register indirect addressing mode, in which the offset address of our data was stored in some register, and the registers which are used to store the offset address are BX, BP, SI and DI. Now we will see register relative addressing mode. So this register relative addressing mode is just similar to register. It is basically register indirect, right? This is register indirect relative addressing mode. So in this, it is just similar to register indirect addressing mode with some relative addressing, right? So in the meaning of relative addressing is the displacement of 8-bit or 16-bit number can also be given with the register indirect addressing mode, right? For example, we will see the case 1 where move, we will take one example, AL, comma, within bracket, or displacement value within bracket dx. Then second form is move AL, comma, displacement value within bracket BP. Then move AL, comma, displacement value SI, and move AL, comma, displacement value DI. So if we compare these set of instructions with the instruction of register indirect addressing mode, so only thing is we have included here this displacement value, right? Otherwise remaining thing is same. Here this your destination can be 8-bit or 16-bit register, right? So just like previous cases. So here destination can be 8-bit register or 16-bit register. Now here only thing what we have done, we have included a displacement value, which is a relative value, right? Now this displacement value again it can be 8-bit or 16-bit. Now the offset address of our data, right? The offset address of our data will be calculated by adding this displacement value with the content of these registers, right? And we know that for BX default segment is data segment. For BP default segment is stack segment. For SI default segment is data segment, and for DI also default segment is data segment. So now we will take one example. Suppose this is the instruction move AL, comma 05H, right? This is our displacement value 05H, and bx. So now in this case, offset address of data will be calculated by adding this 8-bit displacement value with the content of bx. So 0, 5h plus bx, right? So by this way we can calculate the offset address. Now finally the physical address from where data will be moved to air will be of data will be default segment. Since we are using bx register, so default segment is data segment register multiplied by 10 plus offset address, right? So in this way we can calculate the physical address. Now for example, suppose this is our memory, and in this memory this portion of the memory is our data segment, and let us assume the value of our DS register is 2000. The value of our DS register is 2000H, and the content of BX register is, let us assume it is 3A43H. So here in this case, the offset address where our data is from the base of this data segment. So this is the base of data segment. So from this, how much far is our data from this base will be our offset address, and offset address we will calculate by the value of bx plus 0.5. 0.5 is the displacement. So in this case, bx is 3A43. So in this I will add this 0.5. 0.5h. I will add this. So 5 plus 3 is 8, 4, A, 3. Right? So this is our offset. This is our offset address. So after somewhere here we will find that offset, right? So see, first location offset address is 0000H, and the last location's offset address is FFFFH, right? So these are our offset addresses. So somewhere in between we will find this address 3A48, like this, 3A48H. So in this instruction, move AL, 05H, then within bracket BX. So in this instruction, data from this offset address will be moved to AL register, and here I will write physical address. Right? So physical address of the first location will be 20000H, and offset address of last location will be 2FFFFH, and somewhere in between we will find this particular offset address. So the physical address of this location will be simply from here, data segment into 10. So data segment register is 2000. So in that 20000, right, into 10. After that, add the offset address. Offset address is 3A48. So 3A48, add this. So So this will be 84A32H. This is your physical address 23A48H, right? So data will be moved from this physical address to our AL register, right? How we calculated this physical address? So we know that data segment register value is 2000H. Multiply it by 10, you will get 20000. Now the offset address of first location is 0000. So 20000 you plus 0000. So what we will get 20000, right? 20000. And same way, this last location physical address we can calculate in the same way. Now in register indirect relative addressing mode, the displacement value can also be of 16-bit, right? Now, for example, in place of 8-bit displacement, we are having 3, 4, and 3, 4, 9, 2. This. So here, this is a 16-bit displacement value, right? So now, how to calculate the offset address? Same formula. Here you add the 16-bit offset value with the BX registers. The offset value is 3492H, right? So I will add this value of BX. BX register is having value 3A43. So BX is having 3A43H. And in this we will add the 16-bit displacement. So displacement value is 3492. 3492H. So we will add these two. We will get 3 plus 2 is 5. 9 plus 4. Then 9 A, B, C, D. So it is D, A plus 4. B, C, D, E. This is E. 3 plus 3, 6. So this is our offset address, right? So data is at offset address 3ED5, means somewhere here, right? 3ED5H. This is the offset address, right? 3ED5 H. Hexadecimal. So, what is the physical address from where data will be moved? So we can calculate data segment register into 10. Data segment register is having a value of 2000. So 2000 and you add one more 0, right? In this, add the offset address. Offset address is 3ED5, 3ED5H. Add these. So 5DE3, 2. This is the physical address. 23ED5. 23ED5H. So from this physical address, some 8-bit number will be moved to AL register. And if in place of AL, if we are having AX, then now since the destination is a 16-bit number, so 16-bit number will be loaded in AX, right? So in this case, each memory location can hold only 8-bit number. So data from 2 consecutive memory locations will be moved to AX register. So here we are having 3492H offset. We have calculated the offset address. So from this offset, data will be moved to AL, lower 8-bit of the register. Then the next offset address will be 6ED6H, right? From this, data will be moved to AH, right? So from higher offset, data will be moved to higher register. From the lower offset address, data will be moved to lower register. And if we want that in this instruction, if we want to transfer the data from some other segment apart from data segment, then we have to use this segment override prefix. So that can also possible. So here, if we have used this instruction like this, AX comma ES colon. So now what will happen? This ES colon is a segment override prefix. So with this, what will happen? The default segment for BX register is data segment. But with this segment override prefix, now the data will be moved from ES. So while calculating the physical address, now in place of DS default segment, we have to use now ES extra segment. So same type of explanation is valid for all these 4 instructions. Right? Now we will see based indexed addressing mode. Based indexed, right, addressing mode. Based indexed addressing mode. Now in based index addressing mode, the offset address will be calculated by 2 registers. And 2 registers are, one is base register and another is index register. Right? We have to use 2 registers to calculate the offset address of any data. So we know that there are 2 base registers called as BX and BP. And there are 2 index registers, SI, source index register, and DI, destination index register. So the offset address will be calculated by using the combination of one base register and one index register. So what can be the combination? BX and SI, this can be one combination. This is base register, this is index register, based index, right? You have to take one register from each category. Another combination is BX DI. Another combination can be base register, now use BP and SI. Now another combination is BP DI. So now here the offset address for first case will be the content of BX plus content of SI. We have to add whatever value we will get, that is the value of offset address. For the second case, content of BX plus content of DI will form the offset address. In the third case, content of BP base pointer and SI will form the effective offset address. And in the fourth case, content of BP and content of DI, when we add, then that will be the offset address. Now, the instruction where we are using BX register. So for this, the default segment, here I will write default. Segment will be data segment. So wherever we are using BX register, the default segment is DS. Now for BP register base pointer, we know the default segment is stack segment. So this is stack segment. and here also is stack segment, right? And the instruction can be of this form: move AL, comma, DX within bracket, then SI within bracket. Move AL, comma, within bracket SI and within bracket DI. Move AL, comma, within bracket BP within bracket SI, and move AL, comma, within bracket BP and within bracket DI. So we will take one example. Now let data segment register is having a value 5000H. BX register is having a value 34A3H. DI register is having a value 3333H. And if we write the instruction move AL, comma, within bracket BX SI. So first thing, since the destination is a 8-bit register, so we know that 8-bit data will be moved. Now we have to find out the offset address of that data in particular segment, right? So which segment will be used? So here, since in this instruction we are using BX register and SI register both, but the default segment of BX will be considered, so the data will be moved from data segment. And the offset address of the data is calculated by using the value of BX plus the value of SI. So here, offset address of data will be BX register is 34A3H and SI. Sorry, here we have taken SI. Okay, we'll change it. DI, because we have given the value in DI. Okay, so the value of DI is 3333H. So we add these values. We will get 3 plus 3 6, A plus 3 D, 4 plus 3 7, 3 plus 3 6. This is the offset address, right? 6 7 D 6 H. Now we have to find out the actual physical address from where data will be moved. So for that, we require data segment into 10 plus offset address of data. So data segment register is having a value 5000 multiplied by 10, so we will get 50000 H plus offset address we already calculated, so it is 67B6H. So when we add these two, then we will get a physical address of 20 bit, that is 567D6H. So from this physical address, data will be moved in AL register. And just like previous addressing modes, our destination can also be 16-bit register, right? So if it is a 16-bit register, like this, if it is this, then data from two consecutive memory location will be moved. The data which is formed by adding the offset address of the data which is formed by adding the value of BX and SI will be moved in lower 8-bit register, and the next offset address data will be moved in higher 8-bit register. So this is the example of based index addressing mode. Now with the based index addressing mode, after this there is another addressing mode, that is based indexed, here we can relative based indexed addressing mode. So just previously we have seen the relative register indirect addressing mode. Exactly in the same way, in these addressing mode we can use the displacement value. So that displacement value can be a 8-bit or 16-bit. So here displacement value we have to use. And this displacement value can be 8-bit or 16-bit. And now the offset address of the data will be formed by displacement value plus the value of BX plus the value of SI register. In this first case. In the second case, displacement value plus BX plus DI. And the offset address for third type of instruction, this displacement value plus VP plus SI. Plus base pointer plus SI. And in the fourth category, displacement value plus VP plus DI. So in this way we can find the offset address. So here the displacement value can be a 8-bit or it can be 16-bit, right? And segments, default segments are same. In this instruction, since we are using BX register, so the default value of the segment will be DS data segment. In this case, second case, we are using BX and DI, but the default segment will be for BX, which is a data segment, and for the remaining two cases, the default segment will be SS. And we can also use segment override prefix in these instructions also to change the segments. So these are about the addressing modes of 8086 microprocessor.